Welcome back, this is Elsam. Today in our series, we are going to be looking at percentage error. Now, when measurements take place, there's tendency to be an error. Let's say you have to measure a length and the actual length is 10 centimeter. There's a possibility you measure it as 9.5 or 10.5 over or less. So those errors now, the magnitude of that error is what we give as percentage error. And how do we calculate percentage error? Percentage error is actually the measured value minus the actual value divided by the actual multiplied by 100. Now, get the point. Measured value minus actual value divided by the actual value times 100. Note that this is absolute. We're not interested in the sign. We're interested in how big the error is. So that's what percentage error measures. So the measured value minus the actual value, or the actual value minus the measured value, depending on which one is bigger, but the minus sign is taken care of already by this absolute sign. So measured minus actual over actual times 100, that gives us the percentage error. So remember what I said, percentage error tells us the magnitude or how large the error is. So that's the essence. So let's solve some problems. Number one says, a student estimates a length to be 9 centimeter, but the actual length is 10 centimeter. What is the percentage error? So this is straightforward based on what we have. Straightforward. The student estimates the length to be 9 centimeter. So measured is 9 centimeter. Actual is 10 centimeter. So get it to a student estimates a length to be 9 centimeter. So the measured one or the estimate is 9 centimeter, but the actual length is 10 centimeter. So actual is 10 centimeter. So this gives us what we need to do our calculation. So percentage error equals to what? Actual, or measured rather, 9 minus actual 10, the absolute value, so the negative wouldn't count, over the actual value, which is 10 times 100. So measured minus actual over actual times 100. So 9 minus 10 is minus 1. The absolute value of minus 1 is 1. So we have 1 over 10. And in case you don't understand what I mean absolute value, the absolute value is actually neglects negative signs. So if you have 10 minus 2, that's 8. The absolute value of 8 is 8. 2 minus 10, that's minus 8. The absolute value of 2 minus 10 is actually 8. So you ignore the negative sign. So in this case, 9 minus 10 is minus 1, but we ignore the minus and then we have 1. So 1 over 10 multiplied by 100. So 0 cancels 0, we have 10% there. So our correct answer here will be option C. So percentage error problems are pretty straightforward. Just know the actual, know the measured, get the difference, divide it by the actual value, and multiply by 100. That will give you the percentage error. So that was number one. Now let's look at number two. Number two says, a faulty scale measures 200 lb weight as 190 lb. So a faulty scale measures 200 lb weight as 190 lb. What is the percentage error? Straightforward again. So actual is 200 lb, right? And then the faulty scale measures this 200, which is the actual, as 190. So measured is 190 lb. So with these two values, we can calculate our percentage error. And percentage error is the difference between the two values divided by the actual value multiplied by 100. So let's do it. So we'll have actual minus measured. Remember, anyone can come first, over actual times 100. So we have absolute. So we have 200 minus 190 all over 200 multiplied by 100. So 100 here 1, 100 here 2. Remember that if you did 190 minus 200, you have minus 10. And the absolute value of minus 10 is positive 10. So up here we have 10 divided by 2. Because 100 here, 100 here is 2. And then our answer is 5%. Okay, that will be option what? Option A is 95%, option B is 10%, option C is 5%, and that's the correct option. Okay, so we've done 2 examples on percentage error. Let's see the third one. So example 3 says, what does percentage error of 0% indicate? Okay, this is an interesting one. So if the percentage error calculated is 0%, the question is asking us, what does it represent or what does it indicate? A, the calculation was done incorrectly. B, the actual value is 0. C, the measured value is 0. And D, the measured value is the same as the actual value. Let's even see something. Remember, our formula is measured minus actual over actual times 100. And now, if our measured and actual are the same, let's say 10 and 10. 10 minus 10 will be 0. And 0 over whatever it is times 100, the answer is 0. So for our, remember, our actual cannot be 0, because if it's 0, we'll have an error. So our numerator here, which is measured minus actual, has to be 0 for the percentage error to be 0. Or better still, there was no error in the calculation. So, or in the measurement rather. So our correct answer will be option D, that says that the measured value is the same as the actual value, because the difference between measured and actual, giving us 0, will give us a percentage error of 0%. So I hope that's clear enough. Yeah, I really hope so. So let's move to number 4. The accepted density of a material is 20 gram per cm cube. That's the accepted density, 20 gram per cm cube. In an experiment, you measured it as 25 gram per cm cube. So there's obviously an error. So the accepted or actual is 20 gram per cm cube, right? Now, you measured it as, the measured now is 25 gram per cm cube. Calculate the percentage error. This one is very straightforward. Actual and measured. Once we have this, we'll have everything to get our answer. So percentage error equals to measured minus actual, remember absolute value, over actual times 100. So our measured is 25 minus actual 20 over actual 20 times 100. Okay, so what we'll have here is 25 minus 20 is 5 over 20 times 100. So 20 here 1, 20 in 100, 5. And 5 multiplied by 5, that's 25. So 25% is our percentage error. So for number 4, our correct answer is option C, 25%. Now, this number 5, I want to do number 5 and provide the answer in the comment section. But let me explain something. There's a trap there. The question says, in an experiment, okay, an experiment requires a wire of length 2.5 meter. Watch. A student cuts a wire that measures 245 centimeter. See the difference. 2.5 meter, 245 centimeter. Now, you cannot do percentage error with different units. Remember that we don't keep the units because units cancel out and then we just have percentage. So in this case, you have to convert either the 245 centimeter to meter and then you can solve, or you convert this 2.5 meter to centimeter. So you have the same unit and then you can solve and get your answer. So we have options here. So I'll be waiting for your answer in the comment section. So I remain Elsam. Kindly subscribe to this channel to keep getting interesting solutions to mathematical problems. And don't forget, our goal for this course is for you to score 90 and above in your UTME Mathematics. So follow the course from the beginning to the end and your success is guaranteed.